welcome everyone to this World of Wood webinar, which is to launch the first TDUK technical paper on assessing the carbon related impacts and benefits of timber in construction products and buildings. My name's Charlie Law. I'm the Sustainability Director for TDUK. And for those of you who don't know, Timber Development UK is the new organisation that was formed by the merger of the Timber Trade Federation and the Timber Research and Development Association, TRADA, earlier this year. This paper that we're joined by Jane Anderson today. Jane is the author of this paper. So it's very much Jane's work, this, which has been peer reviewed by a number of experts around the country as well in carbon. So we've got a very, very strong paper here. And Jane is a well-renowned expert on carbon and life cycle assessment and environmental product declarations. So just to give a bit of background on Jane, Jane is the UK expert on CEN TC 350 Working Group 3, which developed the EN 15804 standard and the European standard for EPDs in construction products, and ISO TC 59 SC 17 Working Group 3, which developed ISO 21930, and she recently took over as chair of the B558, the UK Mirror Committee for Sustainable Construction Standards. So obviously very experienced person, Jane. I've known Jane probably coming up 15-20 years now, and she's been looking at carbon for at least that time, if not longer. So there's very much not many people in the world that are more experienced at these things than Jane. What Jane's going to present to you today is what's in the paper. It's a little bit of a sneak preview. We haven't launched a paper yet. We're going to be launching that. We're actually going to put it online tomorrow. And we'll be sending you the links and a copy of the paper as soon as that goes live tomorrow, probably tomorrow afternoon. But I'll hand over to Jane now, and she can actually let you know what's actually in the paper. So thank you very much, Jane. I'll hand over and I'll turn my mic off and let you carry on.
So good afternoon, everybody, and nice to see you all there virtually. Yeah, so as Charlie says, I'm just going to kind of run through the content of the paper and give you an overview. But ideally, what we're hoping is that the paper is a really kind of easy to understand guide to exactly how you assess and report the carbon related impacts and benefits of timber, both at product level and at building level. Yeah, so in terms of the background, you heard I've got a bit of a standards background, but effectively the paper follows the rules that are set out to start off with in EN 15804, which is the standard for European environmental product declarations for construction products. That's been in place. It first came out in 2012, and there was an amendment in 2019 which brought it a little bit more up to date in terms of the indicators and gave a little bit more detail, particularly about how to report carbon and biogenic carbon in particular. So there's that. We also have EN 5978, which is the building level standard that CEN provides, and these two standards kind of mesh very closely together so that the data in EPDs is what you can use at the building level. So we follow that as well. And then in the UK, we have something called the RICS Professional Statement on Whole Life Carbon. So this has basically taken EN 5978 and provided the kind of detailed application of that standard to measure carbon in the UK. So it provides kind of default assumptions that you should make so that we have a kind of consistency when we do these assessments. So for example, in the UK, we assess whole life carbon over 60 years. We look at transport of products based on what's typical, and either to get it to the UK or within the UK. So it kind of gives you those assumptions so that we get some consistency in assessment, certainly at an early design stage, and as we go through. If you don't have exact data when you're making the assessment, then it gives you the defaults. The fourth standard that we use is EN 15485, and this is basically the timber industry's implementation of the EPD standards. So it basically provides the guidance on how to the kind of detailed application of the EPD standard for timber. So that we've relied on quite heavily in terms of setting out exactly how you look, for example, at the end of life and at carbon sequestration. And then the final standard is EN 16449, and that is quite a simple standard, but it basically gives you the rules to calculate how much biogenic carbon is actually contained in wood, and we'll come back to that. So that's the sort of basis of what we've provided to you. This is the kind of context and the background. And as I say, these standards, they all kind of mesh together. They all use a common framework, which I'll show you in greater detail, but it basically breaks down the life cycle of products into various stages and then into individual modules. And so all of these, when we do an EPD, the data is provided in each of these modules. And when we assess a building, we can use the data for those modules to build up a picture for the actual building using exactly the same process. And that's used in the European standards, it's used in these wood standards, and it's also used in the RICS professional statement. And just to say, so the professional statement is the methodology that's being used by the GLA, the Greater London Authority, in their requirement now for the larger projects to actually do whole life carbon assessments. And it's also been referenced, for example, in the requirement for projects to do whole life carbon by the IPA, the benchmarking. So it's the infrastructure and anyway, it's kind of the government's large scale kind of procurement that they've issued a guidance that also links to it. As I say, in terms of life cycle assessment, we break it down into stages. A stage we call it's all the stages here. First bit is the product stage, A1, A2, A3. So within EPDs and building level, these can be grouped or they can be broken down. But it basically, for a tree, for example, A1 would be what happens in the forest, the processes of kind of maintaining and managing the forest and actually harvesting the timber. A2 is the transport, for example, to the sawmill, and A3 manufacturing would be what happens in the sawmill when the timber is actually processed. Then we have the construction stage, A4, transport to site, and A5, the construction process and installations. That deals particularly in A5 with for example, any wastage, what happens to that material and the impact of actually making and transporting that product in the first place and then disposing of it or preparing it for recycling and reuse. So that's all kind of the A stage of the life cycle. Then we have the B stage, and there are B1 to B5, which are all kind of related to the materials, if you like. Emissions in use, the maintenance, repair, refurbishment and replacements. And these, both these life cycle stages are part of embodied carbon. We then, as part of the B stage, going back there, and then up cradle to gate, up through the product stage and the construction stage, and that's commonly called upfront carbon. So that's you might have seen that recently, and that basically is all the impacts up until practical completion. I will come back to one special aspect about upfront carbon in relation to timber, so it isn't all of the impacts and benefits there. And when we look at module B, there's also operational carbon. So this is basically all of the impacts from providing energy into the building for heating, cooling, lighting, ventilation, and for water, so providing hot and cold water into the building. So that's the whole of the B stage, the use stage. And then we have module C at the end of life stage. And that basically covers the deconstruction or demolition of the building, the transport of waste from the building, any waste processing until it reaches the end of waste, or disposal. So if it's put into landfill or if it's incinerated without very much energy recovery, then that's in module C. And again, module C, because it's relating to the materials, is considered as embodied carbon. So we have this kind of split between embodied and operational carbon. And then the final stage of the life cycle we call module D. So basically this is it's not actually part of the building life cycle. It's the benefits that occur beyond the end of the life of the building, or when waste comes out of the building and it's recovered. It basically shows that the benefits of that in terms of avoided production. So quite often you have to recycle, say, metals and then show the benefit compared to making new metal from scratch. That's included in Module D. So it's a kind of an indication of the circular economy. It has to be said, one of the problems with it, though, is if you were to build your building entirely of recycled materials, then your Module D would actually potentially show a big disbenefit of having to produce materials to kind of top up, because you wouldn't have actually generated any waste, and you potentially produce less waste than you've actually used. Scrap, for example, that you've actually used. So it's not a perfect kind of indicator of a circular economy, unfortunately. But this is the kind of life cycle that we follow all the way through. So the big issue with timber, I say issue, one of the huge benefits of timber is that it sequesters carbon as it's growing. And you can see here that 1 meter cubed of timber, when it's growing or as it's grown, is expected to absorb about 1,000 kilograms of CO2, and also beneficially produce about 3/4 of a ton of oxygen at the same time. And that will actually store within the timber, within and this is kind of wet timber here, it will store about 273 kilograms of carbon within it. So this is a huge benefit, taking CO2 out of the atmosphere and storing it while the timber is growing. The question is, what do we do with it when it goes into the building? But we'll come to that. And as I say, this is a huge benefit. It's not just timber that's within the actual kind of tree itself, if you imagine, but we also have what's in the root system, within deadwood, within litter and the soil within forests. And you can see here, this is across Europe. So what's actually in trees is really probably only about 1/4 of all the carbon that's actually stored within kind of European forests. And the very thin kind of green line right at the top of this graph, HWP, is harvested wood products. So that's actually the timber that is stored within, the carbon that's stored within timber that's used within buildings. So you can see that there's actually a lot more in forests than there is in the forest. Sorry, it's not more in forests than there is in buildings. When we look at the same graph in the UK, obviously because we don't have as much forest, I think it's only about 13% of the UK land area is forest, and we use a lot of imported timber, so we have more harvested wood product in the UK as a proportion of our timber, but we still, as you can see, it's quite substantial. So it's really a question of how we show this and how we assess this when we're doing life cycle assessments and embodied carbon assessments. And again, just highlighting kind of a house, typically if it was made with a timber frame and timber cladding, for example, it could store almost 15 tons of carbon CO2. So it's quite a substantial benefit that's basically come into the forestry system and then being transferred into the timber that's being used, and what we actually end up stored in the building. And then at the end of life, there's effectively 2 things that can happen to it. One, it can be released. So if the timber is, for example, burnt in an energy recovery system, then the CO2 is released. Or it can be recovered, and if that timber goes, for example, back into timber products as particle board, for example, if it's chipped and used in particle board, then that timber, the carbon within it sort of basically stays within the building and out of the atmosphere. We also have sort of other routes that it can go in terms of recovery, so it can go, for example, into animal bedding, but those tend to be quite short-lived, and at the end of that life probably it's going to be released again as CO2. So it really is the best option if we can actually recycle timber back into timber products that will have, again, a long life in buildings. So the big question, fundamentally, we have this carbon that's stored in it's brought into the forest or taken into the forest through sequestration and photosynthesis. And then when the timber is harvested, that carbon is obviously transferred into the products that we have. And there is a kind of question about when we should account for this. And I think this kind of diagram shows you 3 different approaches. So the kind of short dotted line that you can see in the top graph is actually just showing the carbon. So in the forest, actually that carbon very gradually accumulates, and you actually have more within the forest because we've got the carbon within the soil and within all the timber that's harvested. When it actually goes to the sawmill and is processed into a product, some of that carbon is being transferred to products like particle board that are being made from the sawdust. Some of it is being used for energy, and we actually only end up with a proportion of it that's within the products. So we could account for it, if you like, being accumulated over the life of the forest and then coming into the product. There is another approach which has been suggested. So that first approach we kind of call backwards looking. The second approach, if we call it forwards looking, would be to say that you harvest the timber and then you start to actually count for the carbon that's being added to the forest that you've replanted. It's already a kind of requirement, and we'll show it, that you can only take account of this carbon sequestration if the timber is effectively being grown sustainably, and that these trees are being replanted. If you're not doing that, then effectively you can't really take account of sequestration. The problem with the kind of forwards-looking approach is that you don't always replant what you harvested. So it then becomes quite complicated whether you would be taking account of a kind of theoretical crop that you just harvested that was being replanted on your land, or whether you'd actually look at the specific kind of forestry that you were replanting. And then what happens if there was, for example, a kind of natural fire? Would you then suddenly tell somebody in their building that they didn't have any carbon because the kind of forest that had been planted on the land had been cut down, so or burnt down? So the kind of forward-looking approach is a little difficult, and what we've actually decided within the standards is that we take a kind of middle ground where we say that the carbon, stored carbon, only actually enters the product system at this kind of year 0 when it's harvested. So we don't take any benefit from the additional carbon that's actually been stored in the forest, and the fact that it's been there for kind of up to 60 years. We take it coming into the system at year 0, and as I say, only when the timber has been sustainably kind of grown, and that there is definitely replanting happening. And you can see, in fact, for all of these, this is looking at the mass of CO2 in the atmosphere underneath, the amount of radiative forcing, so what actually happens in terms of the amount of heat. And there is a difference, obviously, depending on the approach that you take, although it's not sort of over the long term, it's not particularly huge. But I think effectively this middle ground of assuming the timber enters the system from the forest, and that the forest is a kind of separate system, I think that works quite well, and that's effectively what we do within the timber. And then at the end of life of the building, you'll see for all of these that there's a big huge increase, which is effectively what happens when you dispose of the timber, or it's recycled and that timber is transferred. So now, how do we actually calculate how much carbon is in products? And this is where the standard 16449 that I mentioned comes in. There is this formula which is a bit scary, but effectively for timber, just due to the kind of the chemistry of cellulose and lignin, half of the dry mass of timber is basically carbon. And you can multiply that carbon by 44/12, which is the mass of CO2 and carbon, to get the mass of CO2. So it's effectively just a question of knowing how much timber you have, its density, its moisture content, and then being able to find out the dry mass and halving it to get the mass of carbon that's actually stored within it. For other products, it's more complicated, but effectively you have to look at the kind of chemistry to work it out. As I said, you're not always allowed to take account of sequestration, and it is sort of slightly annoying, let's say, that we've got two slightly different approaches in the two versions of 15804. So the new version came out in 2018, I think 2019. 2019, and the old version 15804A1 will stop being used at the end of this year, but there will still be EPDs that will be valid for kind of 5 years. So it's still going to be there. But effectively, 15804A1 looked at whether the timber was sustainable or not. So effectively, there were two routes. One was if the amount of timber forestry forest carbon was increasing in the country, so that's the Article 3.4, and also if it was sustainably managed, so PEFC, FSC. In both of those cases, then you were able to take account of the sequestration. So that was kind of that first approach. What we have now in 15804A2 links to the way that the European Commission's product environmental footprint looks at timber, and they are very keen on ensuring that what they call native forest is not used. So the way they define native forest is basically that it's not managed forest, it's not degraded forest, that there's no kind of harvesting or rotations of taking timber out of it. So it's kind of kind of primary forest where there's no human activity or old growth forest. So that's basically the differentiation there. But effectively, if you're using sustainable timber or reused, recycled timber, in both of those cases, you're able to take account of the sequestration. And hopefully there isn't going to be an opportunity to use any of these other types of timber which don't allow sequestration. Just giving you some information here on the Module 1A stage. So what we do is we assume that the timber, when it is looked at in A1, so this is where the timber is harvested, this is where the kind of carbon comes into the system. And you can see here, this is pretty typical for kind of softwood, that it's got 733 kilograms of stored carbon, CO2 within it, and a relatively small amount of CO2, fossil CO2, that's actually been produced during that process of kind of growing the timber and extracting it, because it's fundamentally a very low impact process. You then got the impact of transporting it to the manufacturing plant. Again, generally these manufacturing plants are located close to the forests, so there isn't huge amounts of transport here. And then the actual manufacturing, again, pretty small, basically because they're using, now it's very, very common in forestry, in kind of sawmilling and timber processing, that they're actually using the timber waste. So the kind of sawdust that you get, the chips from processing it, the kind of bits that are not quite square that you get from having a kind of circular trunk, they're actually using all of that wood waste as a fuel instead of using, let's say, gas or another form of heat. And they're very often also using CHP, so generating electricity through that process. So again, very often you'll find that there's very little manufacturing impact because it's using bio-based energy there. Where we do have more impact in terms of transport to site, particularly seeing as we're importing a lot of timber in the UK. I think about 80% of the structural timber that we use is imported. And then we have the actual process of construction and installation. And again, that can be a significant impact, particularly if you have timber wastage. And the processes of lifting and installing it. When we look through the B stages, so here it's really about maintenance, repair, replacement. The benefit here is to try and, or the way to minimize impact here is in terms of reducing replacements, using timber that's more durable, And the example here is heat treated timber from Vaston, I think, which I can't remember the name of, but yeah, but it basically, because it's been heat treated, it's much more durable than normal timber would be, and it doesn't need the preservation processes. So again, reducing the impact of the building going forward.
It's brimstone, that the name you're thinking of, Jane.
Thank you. That's on the tip of my tongue. And then we have the end of life stage, and this is where it gets quite interesting. So the impact of deconstruction and demolition, generally not terribly big, because it's not a particularly intensive process. Transport can be significant, but not particularly, because most waste processing is now reasonably close to where buildings are being demolished. Then the waste processing, and you can see here there's really quite a significant impact. And this is basically because when we recover wood, or when we use it for energy recovery, that carbon is basically leaves the product system. So it's either emitted when we burn the timber, or it's transferred to the next product system. So you saw that recycled timber has this sequestration, it's able to take it. And because if you're recycling timber, you basically need to take the CO2 out of your system and transfer it to the next system. So it's treated as an emission, even though that timber hasn't actually gone into the atmosphere. And you can kind of disagree with that, but it kind of has to happen, I'm afraid, as a kind of an accounting process. And we may at some point manage to find a way of actually providing more information about the benefits of keeping that timber within the building system and out of the atmosphere. At the moment, that's not possible. And then in C4 here, this is basically just dealing with residual waste from that recycling process there. But if you were, for example, to landfill your timber, it's very uncommon, about 1% of timber is landfilled now. Then the way the standard looks at it, you actually have to report any carbon that hasn't decayed and been released as landfill gas and potentially used for energy. And you have to transfer that to nature. So you would have a substantial emission in C4 if you were landfilling timber, but hopefully that happens very, very rarely. So this is just an overview of where we think timber generally is going, and you can see that actually the vast majority of timber is used as biomass fuel, exported for energy recovery overseas, or refuse derived fuel for the kind of low grade timber wastes. A reasonable proportion, just under a quarter, is actually recycled into wood-based panels, a smaller proportion into animal bedding and surfacing, so kind of equine services, things like that. And as I say, a very small proportion into landfill. And if we look in a little bit more detail, this is just looking at the breakdown for different types of product in terms of where they can go. So you can see, for example, that it's only solid timber that hasn't got any preservative treatment that can actually be used for animal bedding and surfacing. None of the products that have glues in them, so engineered timber or wood panels, products like plywood or chipboard, or any of the timbers that use preservatives, they can't be used for that purpose. Effectively, kind of biomass, using it for energy, all of those can be used, particularly in the large kind of biomass installations that have very good processes in terms of disposing of hazardous timber, for example. So everything can go to that. Reuse, most of these products can be reused, and that's by far the best option if we can. Unfortunately, it's not yet as common as we would hope it could be. Yeah. So this just gives you an overview of where timber can go, and hopefully things like the refuse derived fuel, that's really only for the very low grade, kind of what's left residuals, rather than if you've got a large piece of timber, it's much more likely that hopefully it would either go to wood-based panels or be used for energy recovery. And this is, and just going into a little bit more detail about the percentage for each of these products. in terms of where we expect or think that timber is currently going. So when you're doing building level assessments, these are proposed kind of end of life routes for different types of timber. And so this is the first time we've actually kind of provided this level of detail and information about how you could actually assess the impact of timber at the end of life. But you'll see we haven't included a kind of reuse as an actual percentage there, effectively, because at the moment it's not common. But certainly, for example, for engineered timber, its potential for reuse is really, really high. So we kind of very much hope that that is what will happen to it at the end of life. But obviously, there's not huge amounts of kind of glulam coming out of buildings at the moment. But yeah, so that hopefully will be very useful going forward as the position to be adopted for end of life treatment in EPDs for the UK and building level assessments. I've said kind of reuse is really the best option, and the way the kind of we like to hope things would happen is that timber would first of all be reused where it could be. So we've got this reclaimed timber as its second life. So you kind of try to keep your first life as long as you can, then reclaim, reuse the timber. Then, you know, when that building comes to the end of its life, the next kind of best option is recycling the timber for use in wood panels, so kind of chipboard, and they are starting to look at it, I think, in terms of OSB. I think there's hoping to trial that shortly. And then really the last resort is bioenergy, because once you've done that, obviously you can't use that wood ever again. It's gone, and effectively when we use bioenergy, we are actually releasing CO2 into the atmosphere, and the atmosphere isn't that kind of picky about what type of CO2 it's coming in. So it's only a kind of an accounting that releasing the CO2 is a kind of balanced approach. So really, if we can avoid using bioenergy, that really would be the best option, and only to use that as the last resort. So just a little bit more detail about how this kind of works in detail. So you've got here product one, the first one here. So the CO2 that's going into your A1 to A3 impacts. If, as I say, during the production of, for example, sawn timber, you're also producing sawdust, and that's going into chipboard manufacture, then that carbon that's sequestered in that waste sawdust, that basically travels with it. So that's that kind of bottom arrow that's going down to your parallel co-product. So you lose that stored carbon from the first system, and it goes with so it basically always travels with the timber to that co-product. And then at the end of life, that carbon is either released to the atmosphere if the timber is incinerated, for example, in C4, or if it's being used in recycling, then effectively that carbon is transferred to this product to the next life cycle, and it's there as a benefit, a negative in here. So the plus and minus is effectively the characterization factors that we're using when we're doing the assessments. And then if you look at that second product, product two, again, at the end of life of that product, it's either releasing the CO2 or transferring it to the next product system. And this diagram is basically a copy of what's in the timber standard EN 15485. So effectively that's how it's done. And so you either always have this release or this transfer, and when you have the transfer, it's shown as an emission in the same way. I'm really sorry about my dog if you can hear her barking. No, she doesn't like to be on her own, I'm afraid, and victim of lockdown. Then the second one is actually showing you how we show the impacts of sequestration in module D. So this is where you've got timber at the end of life of a building, where it's being, for example, recycled into particle board, how do we show the benefit of that, what actually happens in module D. So in module D, we would show the processing that happens after what we call the point of, after it reaches the end of waste state. So effectively sawdust is kind of, it needs to be processed into the waste wood needs to be processed to actually get it to the point where it makes particle board, and then you would substitute kind of virgin, or you chip it, and then you'd substitute kind of chipped or sawdust from new timber. So that's the kind of the balance here, and you can see that obviously the timber, the waste kind of timber, when it comes into this second product too, it's bringing with it its sequestration, but obviously when it's substituting timber, that product also has sequestration. So effectively those two things balance out, and the sequestration really isn't, there's no benefit shown in terms of sequestration. It's really only the impacts of making the virgin kind of timber product that we're substituting. So that's in module D. So you shouldn't really see big negatives that would be related to sequestration in module D if it's a timber product substituting a timber product. It is different, however, when you're substituting non-biomass. So for example, if you're using your timber for energy recovery and your product is electricity and heat, for example, then your substituted virgin product would be normal grid electricity, which obviously doesn't have the sequestration. Actually, that's not such a great example, but if you were sort of a timber product and it was substituting something that wasn't timber, then you would be able to show that benefit because you're not deducting the sequestration again. Yeah, so if you're actually making energy from it, then obviously you burnt the carbon, so you'd have released the CO2. So you wouldn't show any benefit. It would just be the benefit of avoiding grid electricity. So over the building cycle, this is where it again gets interesting. What we have, I showed you kind of upfront carbon and embodied carbon, and then whole life carbon, which is actually including the operational carbon. So it's the whole impact of assessing the building. What we have, if we look at upfront carbon, normally, and certainly within the standards, you're expected to include the sequestration, the biogenic carbon, within kind of A1, within that upfront carbon. The problem that we have is then obviously buildings that use a lot of timber have a negative emission, and that isn't really kind of correct, if you like. There is a big benefit from the carbon storage, but it kind of produces the wrong kind of incentives. So we do want people to build buildings out of timber, and we want people to use timber to substitute other materials because that's beneficial in terms of the impact. But we definitely don't want people to put, if you like, too much timber into a building, because it's a way of offsetting other kind of impacts from using other materials. So when we assess upfront carbon, you'll see that the purple kind of section here, it actually excludes the biogenic carbon. So within the RICS guidance, the professional statement, and within kind of other ways that where we're just looking at upfront carbon, if that's all you're reporting, or if you're reporting an upfront figure on its own, then you would exclude the biogenic carbon that's included within it, although you can give that information as additional information. But when you look at embodied carbon over the whole life cycle, then you can show that biogenic carbon uptake in module A, and then its release or transfer in module C. So that's just explaining how that works. Yeah, kind of rushed through, but the technical paper, as Charlie said, this is the kind of cover of it. It'll be ready tomorrow. So I hope you find it really useful, and hopefully there's some time for some questions.
Absolutely, Jane. Thanks very much for that. We've got about 15-20 minutes for questions. So thanks very much for going through that. Perfect timing, really, Jane. Absolutely. Thanks very much. We had a few questions coming through. If we start off with the first one I've got here from Andy is, why is sending timber to landfill worse than burning? I would have thought that it would be a continuation of the sequestration rather than releasing it back into the atmosphere. So I wonder if you can just say a few words around that.
Yeah, so, well, timber in landfill is an interesting one. There's been quite a lot of work in Australia where they've kind of gone into historic landfills and found that very little of the timber has actually decayed. But then there's other work that kind of considers that quite a lot of it, in fact, almost all the cellulose part of timber will actually decay in landfill. I think potentially it's a lot to do with the other things that are being put into landfill with it, and the conditions within the landfill, and the kind of temperatures and things like that. So certainly within the UK, the Environment Agency assumes that timber, other than the lignin, will be decaying in landfill and creating landfill gas, and their estimates of how much landfill gas that's available and can be recovered and used for energy is kind of based on that. I imagine that if there was something very wrong with that, then kind of historic landfills wouldn't be emitting as much as they expect. So that's the kind of, I don't know, but we when we've looked at it, we've assumed or used the assumptions and the data that's come from the Environment Agency research for what happens in landfill, and on that basis, a lot of the timber does decay, and unfortunately when it decays it's producing both methane and carbon dioxide, and some of that is escaping, although now there's obviously they try to capture as much of that as they can to actually use it to generate energy, but it's still kind of one of the worst options because of that release of methane, because it's 28 times worse than CO2, or potentially more, depending on the time frame. So that's basically why it's better
to burn it than it is to landfill it. Thanks, Jane. One here from Will Arnold. Thanks for your presentation. Could you talk a bit about whether or not that you think the standards incentivize people to design for deconstruction and reuse? And I think you sort of a few points here. If C3 emissions are the same regardless of end-of-life destination, there are no carbon benefits to design for deconstruction. If carbon is regulated or taxed, there therefore be no benefit to design for deconstruction. How do we encourage this to happen anyway, or will the standards be updated to do this?
So I think the standards do effectively look at this, but it's not, if you like, in A1 to C, it is in module D. So if you're replacing a product rather than kind of downcycling as most recycling is, then the benefits are bigger. So certainly, for example, for steel and for concrete, if you're able to reuse it, the benefit is much better than if you're just recycling it, because when you recycle it, you have to have the impact of the EAF process, if you like, before you can show the benefit of the BOF, whereas if you're reusing it, you get the whole benefit of the BOF. With concrete, you, instead of replacing aggregate, which is very low impact, you're replacing kind of concrete, which is a much higher impact. I think, when you look at timber, there is a benefit for replacing it, reusing timber rather than recycling it. One of the kind of difficulties is that the energy recovery, because you're substituting fossil fuels, that always looks quite good. It is gradually becoming much less beneficial, if you like, to use energy recovery because the grid is decarbonising. I think if people, we're updating the RICS guidance, and I think one of those things that we'll do is be kind of much clearer about how to treat reuse, and what kind of things you would need to demonstrate in order to be able to use kind of recycling or reuse kind of end of life rather than recycling end of life kind of impact information. So I hope that it will get better. I think the standards are kind of there. It's yeah, it just doesn't always show as much benefit as you'd hope.
As we'd like, absolutely. Good question here from Akiboye. Is there a difference? Is there any difference in carbon sequestration for different timber species?
So they all basically store half of their dry mass as carbon, but obviously denser timbers, so the kind of hardwoods will store more per meter cube than, let's say, balsa wood would be the kind of example that a meter cube would have the least amount of sequestration, but per ton it's kind of similar, but per meter cubed, the denser the timber, the better. But obviously, yeah, they're all half, just because most trees are lignin and cellulose, and they're both very close to half carbon anyway.
So just to sort of expand on that, so for most softwood species that we'll use for a timber structure, you know, we can generally use a similar figure for all the different timbers, and most of the stuff we use, they're all very similar. 700
to 800 is
yeah. And obviously that'd be on the EPD for the particular product. So just have a look at that. One here from Mike. Please, could you explain a little about designing for deconstruction? If a building is designed without this in mind, it feels that it should be dealt with differently compared to one designed for deconstruction, thus increasing the likelihood of straightforward reuse. This appears to be ignored at the moment. It sort of follows on from your previous question, I think, Jane, doesn't it? This one
So, I mean, effectively, if you want to be able to reuse components, then you need, for example, to be screwing them together rather than gluing them, using bolts for steel rather than what's the word, kind of welding them, things like that. It's basically designing so that the building can be taken to pieces, and those components particularly, I mean, let's say it's not a timber related thing, but for steel, you know, if you actually had the stamp with the type of steel, the grade of steel, and where it's produced, for example, then you wouldn't need to test it in quite the same way as if you just got a beam and you don't actually know what was going into the building. Sort of going forward, hopefully the kind of building material passports, that sort of thing will kind of ensure more of that is able to happen. But it's basically putting your building together so that the materials can very easily be separated and reused rather than having to be recycled. I'm not an expert. There's definitely people that know more about it than me, though. But yeah,
we will be doing a lot more work on this at TDUK as well. So yeah, thanks, Jane. And just for people to know, we do have a circular economy group that's looking into things like this and how we can make buildings more demountable. So and obviously, you know, where we can reuse that, from what Jane's saying, it looks like the standards will over time. It looks as though, you know, we will make more account of that reuse with the carbon figures as well, because it's much more beneficial. So hopefully that will happen.
But yeah, I mean, if you're building in a totally standard way, then you shouldn't really be claiming reuse unless that you've done something that really kind of
absolutely
that's going to be possible.
Absolutely. One here from Ollie, which hopefully you've answered, but just clarify this. Will there be an industry standard for measuring embodied carbon for houses? For example, IRBA and LETI have their own methodologies at the moment that differ with what they include.
Hopefully all of them will be following the new guidance that will come out from the RICS professional statement next year when it's updated. So that's the aim and object of it.
Yeah,
and certainly LETI and RIBA are involved in that. So
yeah, could that be something to do with the end of life stuff as well, Jane? Because some of the figures in the end of life for RIBA are a bit out at the moment, aren't they? On you know, I think they sort of allow for 30% going to landfill, and obviously LETI maybe look at something else. So things like that will be updated.
Yeah, we're looking to kind of update all of that, and also, for example, give more guidance about how to deal with renewables and PV that's building integrated or not building integrated, and just try to have something consistent there that follows the standards. Yeah.
Great stuff. And obviously now we've got some much better data that James put together, myself put together for the end of life for timber as well. So that should give you some much better numbers there as well that you can start to use. One here from Philippa: as an agent, the obligation of creating an EPD will this be on the supplier or the customer? Will this depend on the type of product being traded?
So it's always really a manufacturer's responsibility to create an EPD for a product. They're really the only people that have the data to do that. Yeah, so I would say that it stays the manufacturer's responsibility. It's their data, their claim, if you like.
And where are you actually importing a piece of timber, that would then generally be the sawmill we're talking about, would be the manufacturer in that situation, Jane, really, I think, isn't it?
Yes. Yeah, generally. But I mean, we do have, so for example, the Swedish Timber Association have produced EPDs for Swedish timber generally, and I think there are other ones for timber from other countries. So you've got that kind of generic data, as well as specific sawmills and company data.
And just on, and obviously with timber, I think just leading on from what Philip was saying there, obviously a lot of timber is coming from outside of Europe, where obviously a big proportion is from Europe. Near enough, I think something like 85-90% of the timber we import is from Europe. But obviously there's a significant proportion there that's coming from outside Europe. What standards apply to that timber when you're looking at EPDs? Because obviously we've been talking about European standards today, but what standards would apply to those countries?
So the ISO standard is really very, very similar. The only kind of key difference is how you actually treat waste products, whether the benefit of those waste products in production processes is considered as a co-product or in Module D. And really that's, there's very little impact that's likely to have for almost all products. So if you find an EPD, and a lot of the North American ones for timber particularly will be to ISO 21930, effectively you can use that data, certainly the carbon data. Some of the other impacts will be different, but what I would say, if you're using timber from overseas, particularly if it's from kind of Asia or, and this is it, but just be very careful to make sure it is certified timber. So that's where we really need to be careful.
Great, thanks. And then I think Philip just had a follow-on question there, but she's saying, well, some of our customers will buy the wood that they import and then make plywood. In that situation, that would then be the plywood manufacturer that produces the EPD, isn't it? And then they would need to obviously obtain information from the sawmill on the production processes of their impacts to feed into their EPD.
Yeah, kind of. I mean, normally if they're making plywood, then they're using logs, and that would normally, there are kind of generic data sets for logs from forests in different parts of the world. But but it would be the plywood manufacturer to it's their major impact.
So in effect, it's the last product in the chain before it comes to the customer that buys it, in effect, isn't it, Jane?
Yeah.
Where we're coming from is probably the easiest way to remember it.
Yeah.
That's great. Some great questions there. I don't think we've got any more, but if you've got any last minute questions, please, stick them in the chat box now. We're still here. We've still got another few minutes if you've got any last minute burning questions. So we'll answer those in a second, but I think, while we're waiting, if there are any further questions that come through, I think really want to thank Jane for all her hard work in producing this paper. We've been working on this now for quite a long time. I think we first started talking about doing this paper back in February, I think, wasn't it, Jane? We sort of started looking at the possibility of putting a paper together because, we got a carbon working group at TDUK, and it was felt that this information just wasn't there. So really got to thank Jane for all the hard work over the last number of months to get this paper to where it is. I said we're just getting the last few charts and bits and pieces finalised, and so we can publish this tomorrow. And like I say, as soon as it's up on the website, we'll be sending you out a copy. We've got your email addresses from your registration for the webinar, so we'll be sending you out the first copies. You'll be the first to see this as it goes out. We'll also be sending you a copy of the presentation as well. We'll send that. I'm assuming that's okay, Jane. I haven't asked you yet, but I'm assuming you're okay to send us a PDF of the presentation that we can send out. So we'll send a copy of that out to you as well, along with the link. We've recorded this webinar today, so we'll send you a link to the webinar as well. I know some people have asked on the chat, will these things be available? And yes, they will be available, and you'll be able to link to those as well. So anything from you, Jane, from just as a final statement? Happy for everything? Well, I think there's no more questions that have come in. So we're just coming up to time now, so I think that's worked out absolutely spot on timing. Really appreciate everyone turning up today. Really appreciate you coming along. We've sort of on and off, I think we've had over 50 people on this call today, which is really good. And like I say, we hope you enjoy the paper, and if you do you obviously have any questions going through, obviously send them through to us at TDUK, and we'll see if we can get some answers for you on that. So yeah, thanks again. Really appreciate all your time, and hope you have a lovely evening. Thank you very much.